assumed that you already knew something, and I can't because I haven't taught it to you yet. So there's only two things in here that I'm going to teach right now, and then we're going to backtrack and finish the rest of it later. So 2-4, more on slope. The other two words that you have to worry about are parallel and perpendicular. Now, in geometry terms, regular old, good old Euclidean geometry, what does it mean to be parallel lines?
That never touches each other.
Two lines in a plane that never ever touch. They have to be in a plane first off, because if you're in space, two lines never touching, they could be almost anything. But if they're in a plane, we assume, by the way, there's no way of proving that two lines are absolutely parallel, because they go off to infinity. They might intersect someplace way down where, and when they do intersect, it becomes non-Euclidean geometry. And guaranteed me, you don't want to ever see that stuff. It's crazy. You get triangles that have more than 180 degrees, triangles that have less than 180 degrees. It's crazy stuff. All right, so in a plane, two lines that never ever intersect. So let me talk about how lines act in a plane. So you could have them parallel. They would look like this, right? That's the way most people imagine parallels, two lines running next to each other. The scarier part is you could also be the exact same line in not geometry, but in algebra. Because the definition of parallel allows for overlapping. Where geometry, no points are in common, in algebra, all points could also be in common. So it's either none or all. So if they're not parallel, what are they? Oh, if they're not parallel and they're not exactly the same line, what's the other option? Two lines in a plane. Oh Lord, what do? They cross. What's that called? Intersect. So those two would be parallel. Anything else is just an intersection. So for pure geometry, you can only have parallel lines that don't even touch each other. For algebra geometry, they either don't touch each other or they're exactly the same. And then intersection is just two lines that share one point, one common point. All right, so in algebra, if they're running next to each other like they are in the first picture, or they're on top of each other, what must be true about their slopes? They have to be exactly the same. And there's ways of proving it, but this is the way we're going to write it. Line 1 is parallel to line 2 if and only if m1 is equal to m2. Now, unless you took Math 140, you probably don't know what if and only if really means. IFF is not a misspelling of if. I'm not that bad. Basically what it means is you can say, if your two lines are parallel, then your slopes have to be exactly the same. But it also allows you to read it backwards. If your two slopes are the same, then your lines must be parallel. Not too many if-then statements can be totally reversed and still be true. And when they can be, you just put if and only if in between them. Perpendicular, on the other hand, what the heck does it mean to be perpendicular? Are they just intersecting lines? At right angles. So there are two intersecting lines in a plane that form a right angle. All you need is one. It forces all the others to be right angles. All right, so perpendicular is a little stranger. Parallel is easy to show that the slopes are just equal. Perpendicular, the relationship between the slopes is really strange. Do you want to see the proof? Please say no. It'll take a half hour. It will take a half hour to prove of what I'm about to say. So I'll just say it. Line 1 is perpendicular to line 2 if and only if you take the two slopes, m1, m2, and their product is equal to -1. Their product is equal to -1. So parallel is real simplistic. Their slopes are exactly the same. Perpendicular is a little stranger. Their slopes product is the opposite of 1, which is kind of a little strange. But there's a reason behind it, and I can prove it. I really can. It's just none of you will like it. Actually, yeah, I'm absolutely sure about that. All right, so this opens up some nicer things. So if I start off with a slope, and I say, well, what's parallel to it? And what's perpendicular to it? We should be able to do this rather quickly. So, slope. I have a slope of a line that is 3. What would be the slope of a line that is parallel to my original line who has a slope of 3? 3. Because parallel slopes have to be exactly the same. What would be the slope of a perpendicular line to my original slope line of 3?
-3.
Negative 1/3. Because 3 times negative 1/3 is negative 1. You can also think of it as negative reciprocals, but weird things happen. If I have negative 2/3 as a slope, what would be its perpendicular slope? 3/2, positive 3/2. What would be its parallel slope? Negative 2/3. Now, you're all going, oh, that's easy. I'll never mess that up. I will ask on the test, give me the equation of a line that is parallel to this given line. The slope of the given line will be negative 2/3, and they change the slope to 3/2. Why? Because in your brain, you think you have to do something. And this is doing nothing. Changing negative 2/3 into negative 2/3. So you're like, oh, that's too easy. It must be the other one. So people switch them around and make things really hard. Keep things simple when they're nice and simple. Now I can ask sillier questions. Oops. Find the equation of a line that is perpendicular to 3x minus 4y equals 16, and it goes through the point negative 6, 4. Sounds easy. What do I need to do first? If I'm going to find the equation of a line, I'm looking for 2 pieces of information. What are they? Might want to go back in your notes. To find the equation of a line, you use point, slope, form. So what are the 2 pieces of information I need? Stop it. I know what the equation is. What do I need? A slope and a point. Point, slope, form. It's in the name of the equation. I have a point, negative 4. So I'm going to use this for part of my equation of my line. What am I missing? Slope. Where's that going to come from? Well, it better come from whatever's left over here, the 3x minus 4y equals 16. So how do I find the slope of just this line?
Using the x and y.
The hidden direction.
Solve the equation.
For y. Solve it for y. So if I'm going to solve this for y, you get negative 4y is equal to negative 3x plus 16. Then what?
Divide -4 by everything.
Divide everything by negative 4. If you divide negative 4 by everything, it would look really strange. So you get y is equal to 3/4 positive x minus 4. So what is the slope of this line? 3/4. What is the slope of the line I want? What kind of slope do I want? Do I want this slope? I want perpendicular. Now, to show that you actually found the parallel and or perpendicular slope, I highly suggest you do this. M perpendicular is equal to. So you can emphasize that I'm looking for the perpendicular slope. What do I do with 3/4? Leave it the same? No, that would be parallel. So I want to make it -4/3. So here's the slope I'm going to use, and there's the point I'm going to use, and then I do the y minus y sub 1 thing. So you go y minus y sub 1 equals m times x minus x sub 1, which is a fancy version of the slope equation. Plug in what we know. Now remember, you're only plugging in for y1, m, and x1. You never plug in anything for x and y, plane x and plane y. So this becomes y minus 4 equals m. Don't you dare look at that. The one in the box. That's why I put a box around it. -4/3 x plus 6. X minus a -6. Alright, and then just solve for y. Distribute the -4/3. That would be pretty. Oh well. I'm stopping doing my calculations for you. You're all getting lazy on me.
-8.
Oh, -8. And then move it over the 4, and you get -4. Well, actually, that's not that bad. That's a nice one. Crazy. They both have the exact same y-intercept. Kind of neat if you think about it. Okay, break time. Ready? Ready? This is where it gets crazy. I have a graph. It looks something like this. Do I care what the graph looks like? No. It's irrelevant. It's a graph. Is it a function? Does it pass the vertical line test? So I can label it as a function. It passes the vertical line test. And if I say I want to talk about this point, A. You know, looking at the x-axis, I want to let x equal A. Then I want to go up to the graph and talk about this point on the graph. I have no clue where this point is. It could be anywhere because I randomly chose some weird function just to draw. So what's the best way of making a coordinate out of this point? Well, the x-coordinate is guaranteed to be A. What's the y-coordinate? Well, if this is a function, f of x, and I want to find out what its y-coordinate is, I take A and I plug it in. So it becomes f of A. So the y-coordinate is f of A. So this is what's considered a general point on a general function. Something I don't even know anything about, and actually I could care less about. We could do it again. Come over here. Here's B. Here's a point. What's the coordinate of that point? B, comma, f of B. Awesome. I have 2 points on a graph that I know nothing about. But I have 2 points. What can I find between 2 points? Just did this last section. 2 points. Determine what? What is it? A line. And then we can find, say it louder, slope. Miss Whisperer, you didn't think you were right. You're right, slope. So I can generate a line. It has a fancy name. It's called a secant. If you go back to your definitions of line segments and circles, one of them is called a secant. And we can find the slope of the secant, also known as the average value of this function between these 2 points. So if we find the slope of the secant, it would be change in y over change in x. And therefore, I'm going back and finishing off 2,4 for you. This is 2,4, by the way. Part of it. So 2,4 says,
I have this function, I have these two random points on the function, I want to find the slope. What's the change in y?
A minus b.
Is it a minus b? Change in y. Y coordinates are always the second one.
Oh, f of a.
Most books write it f of b minus f of a. So the difference of the y coordinates. It really doesn't matter if you write f of a minus f of b, but f of b minus f of a is standard. And then the bottom becomes the change in x, b minus a. This thing is called the average, fancily, average value of f of x, of a function. So here comes the fun part. If I ask you what is the average value of a function, please do not memorize this formula. It's pointless, because all you're finding is, what's this? Well, what is change in y or change in x? Slope. So instead of worrying about memorizing a formula, find 2 points on the graph and find their slope. That's all there is to it. So I'll give you one example and then, no, maybe not. We have time. One example and then we'll do the quiz. I think what gets most people with this question is the wording, and they don't interpret it to be simplistic, and it makes it really hard. So the question would read this way. Find the average value of g of x is equal to 3x squared minus 5x plus 2 from x equals negative 2 to x equals 3. So now, after what I just discussed over here, when you see average value of a function, you think slope. So this whole question is basically just find some slope. And then the brain wave should be going, how do I find slope? What do I need? Well, I either need y equals mx plus b, it ain't going to come out of this, or 2 points. So how am I going to get 2 points out of this mess? All I'm given is a function, and x equals negative 2, and x equals positive 3. But this goes back to something else I said. If I tell you what x is equal to, y'all forgot already. If I tell you what x is equal to, I want you to find y. So if I tell you x is equal to negative 2, your first instinct should be, what the heck is y? Because we're always going to be talking about coordinates, so you always need an x, and you always need a y. So if I give you one half of it, you need to find the other half. So how do I find y if x is equal to negative 2? Plug it into the function. So you do g of negative 2 is equal to 3 times something squared minus 5 times something plus 2. And you plug it in and you go searching for this y value. So when you plug it in, you get this. Negative 2 there, negative 2 there. So g evaluated at negative 2 is equal to 4 times 3, negative 2 times negative 5, which is a grand total of 24, I think. 22, 24, yeah. All right, what else do I need? 3. I need another coordinate, so here's 3. So I'm going to find g of 3, which is 3 times something squared minus 5 times something plus 2. Plug in 3. And then just figure it out. 9, that's 27. So g of 3 is 27 minus 15 plus 2 for a grand total of 14. 14. So g of 3 is equal to 14. Now, I've had people on a test get this far and quit. There's one step left, but they quit here because they don't see the information. What we're looking for is 2 points, right? So my question is, out of the blue mess, what is the coordinate that I just found?
negative 224. Out of the second mass, what is the coordinate I found? 314. And now all you have to do is change in y over change in x is equal to 24 minus 14 over, careful. You started here and went here, so you gotta go here and end here. So it's gotta be negative 2 minus 3. So it's 10 over negative 5, better known as negative 2. So the average rate of change of this function, negative 2. It is asking pretty much the same question. If you started from here and you went to the ocean and it took you 3 hours to get there, and it's, like 400 miles? No, it's not 400 miles, like 200 miles. What would you do to find out how fast you were going? Well, you take 200 and divide it by 3, so it turns into miles per hour. But does that mean that's how fast you were going all the time? No, it's an average. So that's the kind of calculation that you do for average rate of change. All right, I'll write the homework on the board. Get ready for the quiz. It's a nice long one. So just a quick little example on the difference quotient, or not difference quotient, average rate of change or average value of a function. Average value of a function comes in different flavors. Usually it turns out to be a rate, like miles per hour, dollars per ounce, things like that. So when we're dealing with a function, let's say, and I'm going to give it a weird variable. This function actually has a very specific use. It's called the free fall formula. And basically all it describes is the height off the ground after you throw something in the air with a certain velocity. So as my cat keeps going up and down here, it's traveling in one path and then straight up and down. And this function will tell you how high off the ground it is at any time in seconds, so t is seconds. But you don't need to know all that. This is just side notation. So f of t is usually measured, in this case, feet, and t itself is measured in seconds. It's one of the neat physics applications. If you ever take physics, this becomes part of it. So what I'd like to know, well, I better know something first. I need to know when it hits the ground, so I can ask the other questions that I'm interested in. So how do I find out when it hits the ground? Well, t is how long it's in the air, and this whole expression represents how high off the ground it is. So when it's on the ground, how high off the ground is it? 0. So you set this side equal to 0, and you get negative 16 t squared plus 45t plus 6. And you have to solve this equation. Hopefully we have a calculator, because otherwise this is not going to work out really nice. So the only way to solve this is quadratic formula. You're kind of stuck with it. So you're going to have to go negative b plus or minus the square root of b squared minus 4ac all over 2a. Y'all remembered that for the test, right? Didn't want to use it, but you remembered it. So in this case, what's b equal to? 45. Put that here, put that here. A, negative 16. Make sure you bring the sign with it. And C, it's just 6. And then A, of course, again, is negative 16. Now what we want out of this is a positive answer. The bottom is already negative, so I definitely want the top to be, well, negative 2. Surely I'm going to steal your calculator. So I highly suggest you just do the top part first, so negative 45 minus the square root of 45 squared minus 4 times negative 16 times 6. And the top becomes negative 94-ish, approximately. 94.1. Then you're going to divide that by negative 32. 2.94. Approximately, so about 2.9. So this is in the air for 2.9 seconds. Goes up, stops, comes back down, hits the ground. Now, the reason I need to know that is so if I do the average rate of change, I don't want to go any higher than 2.9. So what I'm going to do is find the average rate of change. Of this function from t equals 1 to t equals 2. T equals 1 to t equals 2. So since it's in the air for only 3 seconds approximately, 1 to 2 really should be interesting to look at. I'm thinking I pretty much know what the answer is. So what do? Well, I need this formula, but I highly suggest you don't memorize the formula because on the left-hand side it just says find slope. So to find the slope, what do I need out of f of t, which is here? Well, what am I given? I'm given t equals 1 and t equals 2. So what do I need to find? If I tell you one variable in a function, you want to find the other. And the other in this case is f of t. So I need to find f of and f of, and then plug them into the formula. So you start off with f of 1. F evaluated at 1 is equal to negative 16 times something squared plus 45 times something plus 6. And inside the parentheses goes 1, whatever's in this one. So you put a 1 there and a 1 there. So f of 1 is going to be negative 16 plus 45 plus 6. I lost my calculator again. 15? 35? 35. Okay. So f of 1 is 35. So after 1 second of flight, 1 second of leaving the ground and going up into the air, this thing is 35 feet in the air. Okay. What do I do with this other number? Well, find f of 2. So you do f of 2. That'd be negative 16 times something squared plus 45 times something plus 6. What goes in the parentheses? 2. So this is 4 times negative 16 is negative 64. That's 90, and that's 6. $32. 32. Okay. 32. Alright, now we just need to find the average rate of change. What coordinate do I get from the green block? What point are we talking about in the green writing? 1 and 35. And the second point? 2 and 32. Right from the last lines of each function. The x-coordinate is inside the parentheses, the y-coordinate is on the other side of the equals. I just need to find the slope between these 2 points. So you do change in, well, in this case, f of t over change in t. So what's the change in the f values? Depends on which way you want to read them, left to right, right to left. Basically the y values. So what are the change in y? You just do 35 minus 32. Make sure you don't change the order. 1 minus 2. So the top is 3, the bottom is negative 1. So this is saying that it's dropping at 3 feet per second. Yes. It's dropping at negative 3 feet per second on average between those 2 times. Now the interesting thing is, at 1 second, the object is actually going up. At 2 seconds, the object's actually coming down. You're just catching 2 places where it is, and you're finding the average between those 2. So it's basically